Do you also want to learn about the differences and similarities of false position method with bisection and secant method? Then make sure to watch this video till the end. Hello everyone, I hope you all are doing great. In this video, we will talk about false position method, also known as Regula Falsi method. It is also an iterative method to find roots of an equation. Now let's have a look at this. So here we have formula for false position method. It's very much similar to the formula of secant method. So now let's suppose we have an equation x cube minus x minus 1. Now here we have some starting roots. We have to choose the starting roots where signs are changing. Okay, so when we put 1 in this equation of function, our value of function is -1, which is negative. And when we put 2, we got +5, which is definitely a positive value. So we will take these two as initial guesses. And now we will just put them in the formula. So after putting them in the formula, we got our first value of x 1.16667. Okay, so now put this value again in the formula. But what's the difference? Now the difference comes here. You will not update the value with the previous value, but you will actually see the sign of the value of function, which is negative here, minus 0.5787. We got this value when we put 1.16 in the equation or the function. When we put this value in the function, we got negative 0.5787. Now we will compare this value with our previous value. So the negative function in our first iteration and the negative function or the value of function is present in our x naught or initial guess 1. So we will replace it. Here you can see x naught is 1 and a function of x naught is -1. So we will update these value with new values because the signs of both are same. So in the next iteration, here we will update x naught with 1.167 and function of x naught with minus 0.5787. Now we will have a new value of x in the second iteration, which is 1.25. Now put this value again in the function. Now we again have a negative value, so we will again update the previous negative value. So in the third iteration, we will update previous negative value. Okay, so here again x naught is replaced by 1.25 and function of x naught is replaced by minus 0.28. So now we have answer of our third iteration. Here you can see in the table that in first iteration we have x naught 1, in second iteration we have x naught 1.167, and in third iteration we have 1.25 x naught. But the x1 remains same in all of the iterations. But if we ever had a positive value of function in any iteration, then it might be replaced with x1. If you don't understand it right now, you will understand it better in code. So let's take a look at the code. Firstly, we have defined our function of equation in which it will just simply return us value of the equation. We have our initial guess 1 or x naught equals to 1.0. We have our initial guess 2, x1 is equals to 2.0. And now here we are calling our function false position. And here we have our first parameter equation. It is a function. Yes, we are given a function as an argument in a function. And yes, it's possible. And if you want to learn more about this, you can watch my previous videos. Then we have our initial guess 1 and then initial guess 2. And what's happening in the false position function? Okay, so here we have defined our function. It will be our equation. This is our initial guess 1. B is our initial guess 2. We have tolerance set by default to 1 exponent minus 6. And we have set our maximum number of iterations to 100. And user can change these both when user is calling the function. Now you can see that this complete code is similar to the bisection method. And if you don't know about bisection method, you can watch my previous video. Here we are multiplying the function of a and function of b, and if it's greater than 0, then raise value error because the signs are not opposite. When the signs of values of functions are not opposite, then raise value error, because if we multiply -1 and +5, we are getting a negative value. Okay, now let's suppose if these both were positive, or you can see in 0 and 1 we are getting -1 in both of the cases. So if we multiply -1 with -1, our answer would be 1, which is greater than 0. So that's why we are using this condition. So here iteration counter is set to 0 while iteration is less than maximum number of iterations. We are using this formula, and it is exact same formula which we used in secant method. And again we have one more condition. If value of function of c is less than tolerance, then return c, because it would be our root. Okay, and yes, that would be our answer. And then we have one more condition. If function of a multiplied by function of c is less than 0, then B is equals to C, else A is equals to C. And this part is also similar to the part we did in bisection method. Actually, false position method is a mixture of bisection and secant method. The formula we are using is the formula of secant method. The conditions we are using are the conditions of bisection method. So actually, what's happened in secant method, so what happens in secant method, we update the values linearly. Okay, if we got a new value, then it will directly update the previous value. But in false position method, we will look at signs. If signs are same, then we will update the value. So if function of A multiplied by function of C is less than 0, then B is equals to C, else A is equals to C. I have shown how it is working in my previous video of bisection method. You can follow that video. And at last, we are having an increment in our iteration counter. And once we are out of this while loop, it will just print number of iterations. And if we are out of while loop, then it means that our maximum number of iterations has already been reached and no convergence was found there. Okay, so it will just simply print that. And last, we are just returning our C. So if I try to run this code, let's see what will happen. So it found our root, that is 1.324. Now, if I change the tolerance here, then our root might be different. So I did a small change here. I am also printing the iterations when our value reaches less than tolerance. So when I run this, we will know it took 24 iterations to reach this root. So yep, that's all. That was the false position method. It is a mixture of bisection and secant method. Formula we are using was of secant method, and the conditions or the thing which we were doing with the value updation was completely similar to the thing we did in bisection method. And that was all. If you really enjoyed this video or got to understand something about Python or false position method, then don't forget to like, share and subscribe. And yep, that's all. And if you want more of this type of content, then keep following.